Do you want to build a system that is 7% more accurate than GPT-4o? Then you need to check this out, mixture of agents. This is a very interesting technique in which large language models collaborate between themselves by iteratively enhancing the quality of the responses of the large language models. This system is composed by two groups. The first group has the intermediate steps and then it has a final output layer. And let me quickly show you how this works. On the intermediate steps, we can see that it is composed on layers and it can have as many layers as we want. Each layer is composed by large language models, which are called proposers, and these large language models will generate a response. We can have as many large language models as we want per layer. So here we can see that these large language models generate a response, and then we concatenate the responses of all these large language models that we have in this layer. Something to consider is that we can choose heterogeneous models in order to increase the diversity on their responses, which will help us to mitigate the deficiencies of individual large language models. In some cases, some large language models are better at performing certain tasks, such as coding, while others are better at performing math-related tasks. Nonetheless, you could also reuse the same models within the same layer. That means that you could use Llama 3 70 billion parameter model here, and then here you could use Gemini, or you could use three different models here. You could use Gemini, you could use Llama 3, and then here you can use Mistral. And if that's the case, you will increase the diversity of the responses. If you're enjoying this content so far, don't forget to subscribe to the channel by clicking on this button because it helps me to create more content. Smash the like button below and turn on the notification bell so you never miss a new video. These concatenated responses will be passed to the following layer, and these large language models that we have here, these proposers, will generate a new response based on the context, and this context will be concatenated again. And these concatenated responses will be passed to the following layers, and so on. So in our final layer of the intermediate step, we will pass the concatenated response as an input to the final large language model. This large language model is called an aggregator, and this large language model objective is to summarize the responses from previous large language models into a high quality response. And here you can see that we also fit the responses of the previous large language models. And on this case, when you are choosing a large language model to be an aggregator, you need to consider that you want a large language model that is good at summarizing information, such as GPT-4o or Llama 3 or 𝘁 1.5. So this large language model, the aggregator, will have this as an input and will generate a response that will be provided to the user. And in this paper, they show the results of how to build the mixture of agents. They mentioned that they use 3 layers and each layer has the same models. For the proposers, they use these open source models, such as the 𝘁 110 and 72 billion parameter models, the Wizard LM with 22 billion parameters, Llama 3 70 billion, Mistral 22, and DBRX Instruct. And for the last layer, they tried different models. When they used 𝘁 1.5 110 million model, they got the most accuracy, which is 7% higher than GPT-Omni. And for the most cost-efficient solution was built using 2 layers with the same models that we have here, with the same proposers, and they used the large language model 𝘁 1.5 72 billion parameters. And this model is 1.8 more accurate than GPT-4o. And now let me quickly show you how to build this in Python. Here we have the repository of the authors of the Mixture of Agents paper. We can proceed to clone this repository, and if we check the README file, we can see that one of the things that we need to do is to specify an API key. In this case will be the API key of Together API in order to use the models that they have in together.io, and then proceed to create a virtual environment and install the requirements in order to run this application. And then we can run the application by typing python-bot.py. I already created an API key in together.io, and I'm gonna be leaving in the description below the link so you can also do it. And now let's check the Python code. And here I have the Python code, so let's run this application together. Python bot.py, and here we can see that a print statement is displayed, and they specify here that these large language models are used as reference for this demo, and these reference models are basically the proposers that I showed earlier. Then they ask which main model do you want to use. In this case, they are suggesting as a default value 𝘁 2 72 billion instructor model. In this case, the main model is the aggregator that will synthesize all the answers generated by the proposers. Let's keep checking this code. Here we can see that we can change the reference model, so you just need to specify a different large language model here. And if we keep checking the code, we can see that they have here the function that starts the conversation between the user and the mixture of agents. Here they perform the initial setup of the model and specify, for instance, what main model do you want to use. Let's say that we want to use Qwen2 72 billion, but you can see that you can change this model here. You just need to change the default value and that's it. But let's say that we want to use that model. And then we can see that the second question is, what temperature do you want to use? Let's keep the one that they have as default, which is 0.7. And then they specify what max tokens do you want to use, which are basically the maximum amount of tokens that you want the large language model to produce. Let's keep the default one, and then let's start asking questions to the large language model. In this case, they have top things to do in New York City. Let's also keep the default one and see what happens. So here we can see that the first step will be to query all the models. So it will ask the same question, which is top things to do in New York City, to the 4 large language models that we specified earlier, which are the proposers that were at the top of the code. And then it will try to generate a response on each one of these large language models. Something that I noticed is that this API is not very smooth, and you can have this error message very frequent, in which they display that you have rate limited even though that you have not asked 60 queries per minute, because this is the first time that I execute this code now. Nonetheless, they have a delay function that will retry to generate the responses. If we keep scrolling down, here we can see that the 4 large language models, the proposers, were able to generate an answer, and then here we can see that this answer was aggregated and given to the aggregator large language model that provided this final response that we have here. And here you can keep asking more questions to this mixture of agents. If you want to have a high-level understanding of what they are doing on the code, let's check it out in more details now. Here they have the user question that is being asked to the large language model, and here they have the code to query all the large language models. They execute the process function that has inside the generate with references. And in this case, since we are working on the first layer, we will not have any references because we're basically here and we're not providing any reference to the large language model. We'll go to this part of the code in which we need to feed the model that we want to use, the messages, which is basically the user question. In this case, it was top things to do in New York City, the temperature, and the maximum tokens that we want to generate in the answer. So if we check this generate function, which is generate together, we can see that they have a delay here that goes from 1 to 32, and they send a message to this API endpoint in which they do a post request. They specify the model, the maximum tokens, the temperature, and the user question. And from this function, we will be able to obtain the responses of the proposers one by one. But then, by the time we go to our second layer, this part of the code will be executed, and we will insert the references as an input to the large language model, and this is what we have here. These concatenated responses are inserted to the large language models in the second layer. And let's check this function out. And in this function, we can see that they specify a message to the AI system, which is you've been provided with a set of responses from various open source models. Your task is to summarize these responses and so on. And then here they append the responses of the large language models that is used as an input for the following large language models. And here we can see the function that generates the answer of the final model, which is the aggregator. They specify the model, the temperature, the maximum tokens, the message, which is the user question, the references that I showed earlier, which are the generated answers from the large language models that are the proposers. They generate together stream function, in which they have here the API endpoint. They specify the model that they want to use, and then they generate the responses. And then this response that is obtained here is being printed out in the final answers from the model. And then here they print the responses chunk by chunk. And that was it for today. In this video tutorial, I showed you how to build a system that is capable to provide more accurate responses than GPT-4o. I showed you 2 variants, one that has the highest accuracy, which is 7% higher than GPT-4o, or you can also go for the second approach, which is the most cost efficient, which is still better than GPT-4o by 1.8%. I hope you liked this video tutorial and you found it helpful. If you have any type of questions, please leave them in the comment section below. Don't forget to subscribe to the channel because it helps me to create more content. Smash the like button below and turn on the notification bell so you can be the first one to know when I upload a new video. See you next week.